So here's a graph. Which equation do you think the graph represents? You have two options. Use the graph to support your reasoning. Additionally, what information might help you decide more easily whether the graph represents a linear or an exponential function? Okay, so table 2, which equation do you think the graph best represents? First one or the second? Like a 50-50 chance.
Why you put 120 times 1.3?
And what type of function is this one? So table 2 is saying that the exponential function best matches the graph. Now I'm not gonna say which is right or wrong yet, but we know that's an exponential function because it has what equation? Okay, good, and that's been our main focus for the entire unit. Earlier, a student told me, oh, I think it's this one, and when I asked them why, they said, because that's the unit that we're in. Yeah, but a big part of this unit is comparing it to linear functions, which is the first equation, a linear function. So I'm asking the whole class. Is the first equation a linear function?
Yes.
How do you know? Because it's being times by a constant, is that what you said? So we have the variable being multiplied by a number versus like the variable being the exponent. What format are linear equations always in? And this one also is, even though it might not look perfectly like y equals mx plus b, if I were to simplify and rearrange it into this, y equals 3.7 x plus 120, now it looks a bit more like y equals mx plus b, but it is linear. So we can distinguish between the two when they're equations. What do the graphs of linear functions look like? Table 5, or yeah, we could do table 5. What do the graphs of linear functions look like? And does this graph look like a straight line? So usually when I start the day, because I'm really good at the math by now, to be honest, I don't necessarily need to look at the key all the time. So when I first started the day, I looked at it, I was like, oh yeah, that's obviously linear. It looks like a straight line. If you were to graph the both of them, which is probably what you could have done, so like to answer number 2, what information might help you decide more easily whether the graph represents a linear or an exponential function? You could say more x and y values could help you decide. Because when I do graph them, that could have been one way that you decided to figure this out. Also, on a side note, I know we've had like quite a bit of like new people. For the next week or so, we're doing this test, and I need you to just do your best. The stuff will overlap, so I mean, even if like I don't count it against you this time, you're still gonna need to know the stuff for the next few minutes. So just try to keep up best you can. But here's me graphing the first equation, and now here's the second equation. Okay, now first initially I don't see much. You can zoom out and probably see some stuff, but what would be really helpful to do so that I can compare it to the graph that I already have? Because the question was the given graph on your paper linear or exponential? Can we tell based on how it looks right now? Can we? Okay, you guys are telling me, yeah. In my opinion, it doesn't really look like what's on my paper. So that's where I would suggest to adjust the window. How do I do that in Desmos? Okay, so click on the wrench.
And then adjust the x-axis and y-axis.
Adjust the X and Y axis to probably what matches on your paper. That would probably be the best bet. So everyone should practice this at some point. My X axis, looking at the paper, goes from like 0 to 7.5. So I'll make that the same. Starting at 0, ending at 7.5. The Y axis starts at 0 and ends at what? 200-ish. So then now it looks more like what's on my paper. So we can see it is tricky. They look almost identical except for like this region. This is where you see them start to split. So what a good suggestion was earlier is you see how on our paper, it looks like the given line touches right here where X is 7.5, like it looks like it's at 150. To see which line on your Desmos graph, now that you have it adjusted, best matches up with that. Or you could also calculate it and see which one gives you a Y value of 150. All right, but I have the coordinate that I think would help me solve. And when I look at it and probably zoom in, which one does it best match, the red or blue? Are you with me so far? Do you know why I picked this coordinate? Are we paying attention? Why did I pick this coordinate to test out? Can't spend forever on this, and we have plenty of other things, so let's be engaged, let's pay attention. Why did I randomly pick this coordinate? What's the point? Why does that one look helpful to me?
There's a point where the positive.
Okay, good. So like I just said a minute ago, it looks like on the line, you can clearly see the line touches where X is 7.5 and Y is about 150. So you could plug in 7.5 into both equations and see which one gives you an answer close to 150. Or since I have it graphed in Desmos, I could just literally type it in and see which one it best matches. So which equation does our graph best match? The red or the blue? And what type of equation is the blue equation? Okay. So the answer to this one is that it is the exponential equation, this one. Although they do look similar when you look at that portion of the graph. So things that could help you determine for sure would be more X and Y values. Maybe a table of values. Anyone else have anything to add to that? What else would be helpful to determine it? Finding the slope. So basically, what I would think on those graphing questions on your test, there's usually two that look almost exactly the same. I really think the table of values will help you determine which is which. Because like for this example, when we plug in 7.5 into both of them, only one of them gives us an answer close to 150. The other one won't. Question? All right, so then moving on, and I'll come back to this because I know some people are writing, so I just need to briefly read you the goal of today. And it's something that I mentioned, I tried to touch on every time it showed up. And that's comparing our linear and our exponential functions as they continue to increase. You have to be able to compare them, whether they're tables, equations, graphs, and be able to predict how the quantities will change eventually. So just briefly, which one do you think changes the fastest, linear or exponential? Based on what we've talked about so far. All right, well then just think about that throughout the lesson, but by the end of the lesson, you should be able to tell me which one will grow faster. I record all the time, like I'm recording right now, so it's always in the slides in case you're ever absent or want to work ahead. Puzzle piece is lesson 19. And I know I was kind of wishy-washy of when exactly the test would be. I've decided to keep the original timeline that I had to kind of space it out a little bit. So tomorrow will be the last lesson of Unit 5. Then you already have the reviews. Wednesday in class, you'll have time to work on the reviews while I do your binder check. So also I need to add to this list a 5.20 note sheet because that's what we're doing tomorrow. But these are all the pages that I expect in your binder check. Granted, some of you joined the semester late, so I wouldn't necessarily expect those. But you being absent because you're sick or whatever other reason, I expect you to make up the lesson. Like I always have the videos there, the notes are always there. You're gonna take the same test as everyone else, so like you need to know the stuff. So you can take notes on your own paper, or you can help yourself to the note sheets and take notes, but that's what's being checked Wednesday in class. And it's going in the project category because we do all of these collaboratively. So that's what it'll go into, your 20% of your grade. These have been available since Friday, the practice constructed response since before Friday. The practice constructed response is the paper you picked up in addition to today's note sheet. So I will check this one during class on Wednesday when you do the binder check. Otherwise, if you don't get full points, you upload to Schoology. When I have the extra credit study guide available, I'll let you know. It'll be in the same area that you find these two study guides, but I imagine that these two should give you plenty of work to go off of for the test. They're closely aligned. So to-do list in order of importance, that's how I would prioritize everything. And testing schedule is back to what it's been since the beginning of this week. Question? Okay, so next activity, and I'll only go halfway so that people can still write, those of you still write. But the next activity, simple and compound interest. A family has $1,000 to invest and is considering two options: investing in government bonds that offer 2% simple interest, or investing in a savings account at a bank which charges a $20 fee to open an account and pays 2% compound interest. Both options pay interest annually. Here are two tables showing what they would earn in the first couple of years if they do not invest additional amounts or withdraw any money. You and your groups right now will answer 1 and 2. So how do the bonds grow with simple interest? And for the savings account, how are the amounts $999.60 and $1,019.59 calculated? So you technically don't need to fill in the table. You can if it helps you solve those questions. But looking at these patterns, rereading the description, be able to answer 1 and 2. Remember, the bond was the one with the simple interest. Which if you don't know what that means, that's okay. Just see how the pattern's changing and you might be able to figure it out. And the savings account is the compound interest, which is what we've been talking about for several days now. So be able to answer 1 and 2. I'll give you 3 minutes to start out. Table 4, how does the investment grow with simple interest? So describe to me how it's growing.
Well, every year, we do that now, increases by some money.
Okay, so every year it increases by $20. Do you guys agree with that? Is that a fair assessment of how this is going? Okay. I agree. So earlier, I will say that someone tried giving me an equation for that. And the equation they tried to give me, you don't have to write it down. I'm just showing you what they gave me. Was 1,000 times 1.02 to the x power. Why does that equation not work for this situation? Josina?
Because the bond situation, the table is not the
Okay, the table is not exponential. You can see in the y's, it's adding the same amount each time. Exponential functions don't follow that pattern. Exponential functions multiply by the same factor each time. So since this is clearly adding 20 each time, like how much would it have in 3 years? 1,060, and then in 4 years? So that pattern in the y's tells me it's not exponential. I shouldn't have an exponential equation. What type of equation should I have for that one? Linear. So you could also put in parentheses, like, how is it growing? You could put linearly or in a linear fashion, whatever you want to say it. Adding the same amount each time. We'll make the equation in like number 3. But yeah, I will say though, when we did plug it into the calculator and we plugged in their equation when the exponent's 1, like we did get 1,020, but when I plugged in an exponent of 2, it was like 1,040 and 40 cents or something like that. So not quite the same. So where is that $20 coming from? You know? It's a simple interest and it's based off of just what they deposited. So like where other accounts, they'll give you money like compound interest. Will give you money based on the total that you have, even including the interest you've already earned. Simple interest does not. It only does for what you deposited. That's why it's just the same amount each time. Good. Anyway, moving on. So this was 2% of 1,000. That's why it's adding 20 each time. And that's simple interest. Now for the next one, table 8. How is the amount $999.60 calculated? To help you figure that out, take a look at it. Would this be a linear pattern? Is it adding the same amount each time? Okay, so what's the only other pattern we've been looking at? I'm free to say it. We've been trying to compare linear and so it should follow probably an exponential pattern, which has this setup. Or if we're talking about percent change, which we are, you can use the one that has it expressed with the percent change. So there's one. Maybe that will help. So then table 8, what should my A be? 980, because that's always your starting amount, the A. What should my B be? Table 1, can you jump in? What should the B be for this one? 1.02, good. So that would be 1 plus because it's growing. 0.02 is the equivalent decimal to 2%. And then class, what should the exponent be for year 1? You want. They're applying the interest annually, that means yearly, so once each year. That's how they calculated it, you can put in your calculator if you don't believe us. What would be the only difference for this next one? The exponent would be 2. All right, the initial amount's not changing, the interest is not changing, the year is changing. Good, any questions? Okay, so there is that, that's compound interest that you multiply basically by 1.02 each time instead of just adding the same amount each time. Now you're going to make an equation for each. We already kind of did it for this one. We haven't done it yet for the bonds, but you know that for the bonds, it's a linear equation, so it should be in the form y equals mx plus b. So give that a shot, and I'm telling you, this should directly help you with number 3 on your constructive response test. So like if you look at your practice test of it, this is literally that situation. Which one will be a better birthday gift? You gotta make the equation for both, recognize linear versus exponential. Make the equation, plug in the right number, see which one's the best option. But for right now, you'll practice with this one. Write an equation for both, and then decide which option should the family choose. So 3 and 4. Consider doing number 5 using the graphing technology to help you answer which one they should choose. That's probably all we'll get to today, so definitely answer 3 and 4 right now. So table 2, do we have the equation for the bonds? Okay, class, what do you think about their equation? Does it look good? Does it match y equals mx plus b? Yes, because we said this was linear, so it should. M would normally be your slope or average rate of change. It's changing by plus 20 each time. So it should be a positive 20, that's good, times the x being number of years. And y-intercept, the b, is whenever x is 0, so that's perfect. You should be able to do that on your constructed response as well. For the savings account, we kind of already did that. So for the savings, it should be something to the effect of y equals 980 times 1.02 to the x power, where x is the year. Questions on the equation setup? Now, which one do you think is better? Which one do you think will give you more money? Riley?
Savings option, but it's better like in the long term. So after 11 years, something.
Okay, so the savings option is better in the long term. I would agree. So it just depends on how much time. So if like the question on your test was after 18 years, you would have to plug in 18 for the x in both and just see which one gives you more money. It might be the linear, it might be the exponential. If you had to guess, I would say exponential, because exponential functions always will surpass the linear at some point. So like if you graph it, even though it takes some time, the exponential will always surpass the linear. Okay. So don't lose your notes. You have a practice. It's really short. Make sure you do it. And we'll see you guys tomorrow.